In a previous lesson, it was noted that things that have the same size and shape are congruent. It's also been noted that line segments that have the same length are congruent, and angles that have the same measure are congruent. Well, now here's a definition of congruent triangles. Triangles that have all corresponding parts congruent are congruent. Well, let's talk about what we mean by corresponding parts. Triangles have 6 parts, 3 sides, and 3 angles. So for the parts to correspond, we have to have 3 pairs of corresponding sides and 3 pairs of corresponding angles. Well, here are 2 congruent triangles. And for these congruent triangles, here's the 3 pairs of corresponding angles. Angle A corresponds with X, angle B with Y, and angle C with Z. And here's the 3 pairs of corresponding sides. They're all segments, of course, AB and XY, BC and YZ, and AC and XZ. And then we can label the 2 triangles congruent. We label it like this. Triangle ABC is congruent to triangle XYZ. And when we do our labeling, we try to match up the letters of the labels for the corresponding vertices. So in this pair, the letter A is a label for a vertex, and it corresponds with X in the other triangle, B with Y, and of course C with Z. We already know we can make this statement of congruence. Triangle ABC is congruent to triangle XYZ. We could also start at point A and go in a clockwise direction, so we would have triangle ACB is congruent to triangle XZY. And in fact, we could start at any letter we want. And we won't do all of the examples, but here's one more. We start at letter B on the left triangle and go counterclockwise. So then we have to start at letter Y on the right triangle and also go counterclockwise, giving us that it's triangle BCA is congruent to triangle YZX. Well, here we take a look at a triangle, and we copy it and reflect it. So now we have 2 congruent triangles that share a side. So let's mark out the corresponding pairs of parts. Side AB is congruent to side AD. Side BC at the bottom is congruent to side DC. And the one in the middle is shared by the 2 triangles. So side AC is congruent to itself. And for the angles, we have angle BAC congruent to angle DAC, angle BCA congruent to angle DCA, and angle CBA congruent to angle CDA. And that allows us to make this statement of congruence for the 2 triangles. Triangle ABC is congruent to triangle ADC. Here's another triangle. Let's make a copy of this triangle over here. Let's flip that copy and let's slide it back. And after we've done that, we've slid it in a way that the 2 triangles now share angle X. But as we slid the copied triangle back, we have 2 new vertices, one at W and one at V. But the vertex at X is the same for both triangles. So let's match up the corresponding parts. We can start with XY and XV, and then XW and XZ, the 2 at the bottom, WV and ZY. And then they share angle X, so we say that angle X is congruent to itself. And then angle Y is congruent to angle V. And for our final pair of angles, we need to use the 3-letter method because there's 2 possible angles at each one of those vertices. So we have that angle XZY is congruent to angle XWV. And then we can label the congruent triangles as angle XYZ is congruent to angle XVW. Well, in a couple of previous slides, we stated that a segment was congruent to itself, specifically segment AC congruent to segment AC, and we also stated that an angle was congruent to itself, in our case, angle X congruent to angle X. And that brings us to a postulate that states the obvious: any segment or angle is congruent to itself. This is also known as the reflexive property. And we have one more definition. We've just define congruent triangles, well, we can expand on that and get congruent polygons. Polygons that have all corresponding parts congruent are congruent. Well, here's an example. These two polygons have 8 sides each, but they appear to be congruent. And if they are, here's how we could label it. And on the one on the left, I started with point A and went from A to B to C and so on. And it appears to make sure that everything correspond. On the one on the right, I need to start at S and go from S to T to U and so on until I get around to Z. And again, notice we've matched up the labels of the corresponding vertices when we labeled these two polygons as congruent. And you can also see that there's numerous ways to label each one of these polygons. And this example is just one of the many ways. You can start at each vertex and go in either direction at each vertex. So since each one of these polygons has 8 vertices, there's 16 ways to label each one of these polygons. So there's 16 different allowable statements of congruence for these two congruent polygons. In this lesson, we reiterated that things that are the same size and shape are congruent. Line segments that have the same length are congruent. Angles that have the same measure are congruent. We have a definition of congruent triangles. Triangles that have all corresponding parts congruent are congruent. We also went over that triangles have 6 parts, 3 sides, and 3 angles. We introduced a postulate. Any segment or angle is congruent to itself, also known as the reflexive property. And a definition for congruent polygons. Polygons that have all corresponding parts congruent are congruent.